Solving a right triangle. What does it mean to solve a right triangle? The triangle has 6 parts. All right, you can identify the 6 parts of the triangle. It's got 3 sides and it has 3 angles. And solving a right triangle essentially means that you are finding all the missing parts, right? Usually these problems will give you 3 parts of this triangle in some capacity. Maybe 2 sides and an angle, or 2 angles and 1 side, or something like that. And you need to find the rest of the missing parts, right? And there are multiple ways to do this. Some things that we are going to be using today are the fact that in a triangle, all of the angles add up to 180 degrees. Since we are working with right triangles, that means that the Pythagorean theorem will be in play. If we know we know 2 sides, we can use the Pythagorean theorem to find the third. And the most important thing is SOHCAHTOA. Sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent, right? This is all based on stemming from SOHCAHTOA, which is the mnemonic to help us remember this opposite over hypotenuse, adjacent over hypotenuse, opposite over adjacent business. So let's go forward. Number 1, we are given this right triangle. Has a side AB measuring 40. It's got an angle C measuring 25 degrees. And the other thing we're given is that angle B measures 90, right? So that is one of the 3 components here that we are given. And we're looking to find the measures of angle A, then the side BC, and then the side AC. Let's start with angle A. Right, since we know that the 3 sides of this triangle, the 3 angles add up to 180, that means 180 minus 90 minus 25 is going to equal the missing angle, which is going to be 65 degrees. And that's all we need to do for that. Remember that a right triangle in trigonometry purposes is going to be labeled with lowercase letters across from the capitals, but we could use their regular naming scheme for geometry as well, and you'll probably see both. So let's look for side AC first, which is the hypotenuse of this right triangle. Right, so let's solve for AC here. And we're going to do that by identifying the information that we're given. Right, we can certainly use this 65-degree angle, but we don't have to. It might be better, in case we make a mistake, to use the information that we're given. 25 degrees for angle C, and a length of 40 for side AB. So if we're using this, that means that this here is our angle of focus. Right, our angle of focus is down here at 25 degrees. That's going to make 40 the opposite side, and since we're looking for AC, that's the hypotenuse. All right, so let's work from there. The values of opposite over hypotenuse indicates that we are going to be using the sine function. Right? Since our degree is equal to 25, that means the sine of 25 degrees is equal to the opposite value of 40 over the side AC, which is equaling 25. Equaling B. 25 is the angle. So these are our unknowns. These are our knowns and unknowns. 25 degrees is equal to 40 over B. And then we can solve for B here by cross multiplying. And B times the sine of 25 is going to equal 40, which means that B, after we divide by the sine of 25, remember, these represent numbers. They represent decimal numbers, so they can be operated on and divided and stuff like that the same way. So B is equal to 40 divided by the sine of 25, which approximates to 0.42262 after we round to 5 decimal places. And if you have a nice calculator, then you certainly don't have to use that 0.42262. You can put right in 40 divided by the sine of 25. Make sure you're in degrees mode. 94.64806. And this is going to be rounded to 5 decimal places. You can round however you need to, however the instructions mention. And the next thing we're looking for is the side BC. We can use the Pythagorean theorem because we know now that this is equal to 94.64, 94.65. We know that this is equal to 40. So we can plug that into the Pythagorean theorem to find the value of side BC. But let's use trig again in order to figure this out. And again, what I like to do is to use the information that is given to us rather than the information that we calculate. So let's switch our angle of focus away from, sorry, let's actually keep our angle of focus because we're still looking at 25, okay? We're still looking at this 25-degree angle, so we're still focused here. That means this is still the opposite, but that means that down here, our missing value is going to be the adjacent. So since we're using 40 and we're using this 25-degree angle, that means we are looking at an opposite over adjacent ratio, which we know involves the tangent function because that's what SOHCAHTOA says. The tangent is equal to opposite over adjacent. So the tangent of our angle of focus, 25 degrees, is equal to 40 over what we call A, because that's across from angle A. So cross multiplying this gets A times the tangent of 25 equals 40. And A is equal to, in that case, 40 over the tangent of 25. All right, the tangent of 25 is equal to 0.46631. So A is equal to 0.46631. Oops, sorry. That's equal to 40 divided by 0.46631. And again, we're getting this from dividing by the tangent of 25 on both sides. All right, I'm running out of space here, so let's write down A is equal to 85.78028. All right. So number 2, I typed out. In triangle XYZ, we have angle X equaling 90. So let's draw a right triangle. All right, we can draw it like this. Put a box over here, indicating that angle X, because we're told is equal to 90, and it says that side X is equal to 21. Now again, because we're drawing our own triangle, it's important that we know how the triangle is named and how the triangle is referring to. It's referring to side X across from angle X, so that's the hypotenuse. And we can put Y up here, and you don't have to. You can put Y on the bottom and Z up top if you want to on this diagram, but I'm just putting Y up here. And it says that this is equal to 14, right? Is that referring to the angle or the side? That's referring to the side because it's a lowercase letter. So the side over here is equal to 14. Right, that puts this as missing, and that also puts these two angles as missing. Right, so solve for the remaining parts means we're going to solve for those two values. Let's solve for angle Y first. Sorry, not angle Y. Let's solve, let's solve for angle Y. So the information that we're given, we have an angle of focus up here. That means opposite and hypotenuse here. So what deals with opposite over hypotenuse? Once again, the sine function. All right, so the sine of angle y, that's the unknown part, is equal to opposite 14 over hypotenuse 21, which can be reduced to 2 over 3, but does not really have to. In the case where you're looking for the value of an angle, and you know the value of the ratio that this trig function takes on, that means we are going to use the inverse sine function. So the inverse sine of 2 over 3 is going to equal y. And that means y is going to equal, after we put this in the calculator, 41.81031 degrees. Let's find angle z. And again, we like to use our given information instead of our calculated information. Forget that there. So let's erase this box. And let's put our angle of focus down here. All right, so again, that's going to not change the hypotenuse label, but because our angle of focus is changing, that's going to change the adjacent label, right? Adjacent over hypotenuse indicates the use of the cosine function. So the cosine of z is going to equal in 14 over 21, which again is equal to 2 over 3. So we're missing the value of the angle, which means that we're going to be using the inverse cosine function. So the inverse cosine of 2 over 3 is going to equal z. And again, we're using this, looks like an exponent of -1, but something you should know is that it's not. This is inverse. This is just inverse. This is the way inverses are written in shorthand. So in our calculator, we'll put in the inverse cosine. We'll put in that 2 over 3 ratio in the parentheses, close it up, and end up with z equals 48.18969. Again, rounded off to 5 decimal places. This is degrees. The last thing is finding the measure of yx, or xy. All right, we can use the Pythagorean theorem because we know the value of one of the legs. That's 14. We can call the missing side lowercase z. 14 squared plus z squared is going to equal 21 squared, right? The hypotenuse is always left alone on its island. This is going to be 196 plus z squared is equal to 21 squared, which is equal to 441. Subtract 196 from both sides, and z squared is equal to 245. Once we take the square root of both sides, that means z is equal to positive or negative square root of 245. Since this is a geometry problem, we don't consider the negative answer. We don't consider the answer that makes the side of this triangle to be negative. So z is going to equal, after using factors of 49 and 5, z is going to equal 7 radical 5 as an exact answer. If you did use trigonometry to solve for that side, you probably won't get 7 radical 5. You'll probably get a decimal approximation. Thank you for watching.